Hello friends, thanks for watching Edupedia Word videos, virtual word free education. In this video, we'll be learning about relationship between zeros and coefficients of a polynomial. The convention used here are the coefficients of different powers of x starting from highest till the lowest will be denoted by a, b, c and d, whereas the zeros of the given polynomial be denoted by alpha, beta, gamma, etc. depending upon the requirement. Now, in the previous video, we have derived that maximum number of zeros is equal to the degree of polynomial. Now, we know that for a linear polynomial, the degree is 1. Let us derive the relationship for such a polynomial. Now, if degree is 1, then the maximum power of x is 1. That is, in general, we can have a coefficient a and a constant term b along with it. Now, to find the zero of linear polynomial, put p of x equal to 0. That is, a of x plus b equal to 0, which gives us x equal to minus b over a, which is the required 0. Let the 0 be denoted by alpha. Therefore, alpha equals minus b by a is the required relationship. Now, here is factor theorem. The theorem says if r is a zero of px, then x minus r must be a factor of px. The factor theorem will be used in quadratic polynomial derivation. Now, the degree of a quadratic polynomial is 2. We'll derive this result. Since degree is equal to 2, therefore maximum power of x will be 2. Thus, we can have the lower power as x raised to power 1 and x raised to power 0, which is nothing but 1. To generalize the result, let the coefficients be ax square plus b of x plus c into x0, which is nothing but 1. To find out the zero of such a polynomial, we have to put p of x equal to 0, or a of x square plus p of x plus c equal to 0. Let the zeros be alpha, beta. Since degree is 2, therefore maximum possible zeros will be 2. Now, the factor theorem says if alpha is the 0, then x minus alpha must be the factor of px. Similarly, x minus beta will also be the factor of px. Now, consider a number, say 210. We can factorize it as 21 into 10, which can be further factorized as 7 into 3, and the 10 can be factorized as 5 into 2. Therefore, all in all, a set of numbers of the factors of 210 will be 2, 3, 5, 7, 10, 21 and 2 1 0. If we take two numbers at random, say 2 and 5, since both 2 and 5 are factors, this product will also be the factor of 2 1 0. That is, to have 2 1 0, we will need a number k multiplied by this product, which here is 21, because 5 into 2 equals 10. Similarly, if we take 2 1 0 and 10 as the two numbers, then to get 2 1 0 again we need a number k, which here will be 1 by 10. Thus, here x minus alpha and x minus beta are two factors of px. To get p of x as a whole, we will again need a number k. Now here k can be a constant, a real constant. We can exclude variable, that is x, from k, because see, these two terms have degree 1. Therefore, when the highest powers of these two terms will be multiplied, we get the maximum possible degree as 2. Let us clarify this. This on decomposition will give x square minus alpha plus beta x plus alpha beta. Now we have degree 2 here, and the degree of the original polynomial was also 2. Therefore, there is no need to multiply any variable x to increase this degree to the polynomial px. Thus, k is a constant, more precisely a real constant. Now say this equation be 2 and this be 1. Now from first and second, we have ax square plus bx plus c equal to k of x minus alpha x minus beta. Ax square plus bx plus c equal to k of x minus alpha x minus beta. Now on decomposing the RHS, we get x square minus alpha x minus beta x plus alpha beta, which gives us kx square minus k alpha plus beta. I have taken minus common from these two terms along with x, plus alpha, beta and k. On comparing the x square terms on both sides, we get a x square equal to kx square, or simply a equals k. That is, if we substitute the value of k over here, we get ax square plus bx plus c equals ax square minus a alpha plus beta x plus alpha, beta and k, or a. Now compare the terms including x. We get b equals minus a alpha plus beta, implies that b over a equals minus alpha plus beta, or alpha plus beta equals minus b over a. Now alpha and beta were the two zeros of the given quadratic polynomial. Therefore alpha plus beta is the sum of zeros. Thus we can write sum of zeros equal to minus. Now b here is the coefficient of x, which was our original polynomial. Therefore we can write coefficient of x over, again a is the coefficient of x square, coefficient of x square. Thus sum of zeros equal negative of coefficient of x over coefficient of x square, or simply alpha plus beta equals minus b over a. Similarly, compare the constant term, that is c and alpha beta a. We get c equals alpha beta a, implies that alpha into beta equals c over a. Now alpha and beta means product of zeros, which is equal to c, which is the constant term of the given polynomial. Over a was the coefficient of x square. Therefore product of zeros equal to constant term over coefficient of x square in case of a quadratic polynomial, whereas sum equals negative of coefficient of x over coefficient of x square, or simply minus b over a. See, this is the result derived by us. Now, before proceeding towards cubic polynomial and its relationships, let us have some questions regarding a quadratic equation. Friends, we have derived that if ax square plus bx plus c is a quadratic equation and alpha and beta are its roots, then the sum of the roots is equal to minus b over a, whereas the product of roots equals c over a. Now a question says, find a quadratic equation whose sum of roots is 0, whereas product of roots equals under root of 5. So let us have assumption that the required quadratic equation is this one. Now sum of roots is 0, which means this term is 0, that is minus b over a equals 0. Friends, if any fraction is 0, fraction means numerator over denominator in simple words. If this fraction is 0, then this implies that numerator equals 0 and denominator is a non-zero term. Denominator can be any term like 1, 2, pi, even negative, etc. In simpler words, 0 over 1, 0 over 2, 0 over pi, all are 0. Therefore b equals 0. Now product, that is alpha beta, equals under root of 5 for the given question, which implies this term c over a equals under root of 5. Now to simplify this equation, we can write this equation in another form. Friends, if there is a equality that is 2 is equal to 2, which is right. Then if we divide whole of the equation by a constant term, say for example 2, it becomes 2 by 2 over 2 by 2, which implies 1 equals 1. That is, if whole of the equation is divided by a constant term, then the equation remains true or same. That is, here if we divide the one equation by a constant term, say a, the equation becomes ax square plus bx plus c equals 0 upon a and 0 over a, which will give us ax square over a plus b over ax plus c over a, again 0 over anything equals 0, which implies x square plus b over ax plus c over a equals 0. Now this equation is comparatively easy for substituting b by a and c by a values. Let us name this equation as 2. Now put the value of either b or b over a here. We get x square plus 0 x plus under root 5 equals 0, which means x square plus under root 5 equals 0, which is the required answer. Let us have one more example. Find a quadratic equation having sum of roots as 4, whereas product of roots as 1. Again, let us have the assumption that our quadratic equation is of the form equal to 0, which can be again rewritten as, which is proved in the previous example. Now sum, that is alpha plus beta, is nothing but minus b over a. Therefore minus b over a from this part equals 4, implies that b over a equals minus of 4. Similarly, product alpha beta equals c over a, which is equal to 1. Therefore, substituting these two values in equation 1, we get x square plus minus of 4 into x plus 1 equal to 0, which implies x square minus 4x plus 1 equal to 0, which is the required equation. Now let us derive the relationship for a cubic polynomial. Friends, cubic means degree 3 for a polynomial. Therefore, we will be having the highest power of 3 and the subsequent powers as 2, 1 and 0. Let the coefficients be a, b, c and this constant term as d. Now if it is a cubic polynomial, then maximum zeros in number will be 3. Let us have this particular case, which will be covering all the cases. Let the zeros be alpha, beta and gamma. Therefore, by factor equation, x minus alpha, x minus beta and x minus gamma are the factors of the given quadratic equation. Now k is justified, which has been proved in the derivation of quadratic equation, to be put in front of this equation. Therefore, we can easily substitute the value of 0 as this one. because the factor theorem gives this as the equation of the cubic polynomial, whereas we have assumed the value of cubic polynomial as this one. Thus we get ax square plus ax cube plus bx square plus cx plus d equals k. We can also decompose these two factors as x square minus alpha into x minus beta into x plus alpha beta into x minus gamma. Again, we can also decompose these two factors as x cube minus alpha x square minus beta x square plus alpha beta x minus gamma x square plus alpha gamma x plus alpha beta gamma x minus alpha beta and gamma, which implies k x cube minus alpha plus beta plus gamma x square plus alpha beta plus beta gamma plus gamma alpha x minus alpha beta gamma. Now if we compare all the terms, we'll be getting clearly kx cube and ax cube are comparable terms, therefore we can substitute a in place of k. Thus we get b equals a negative alpha plus beta plus gamma. If we compare x square on both sides, because this a can be merged here, which implies minus b over a equals alpha plus beta plus gamma. Now compare again the terms having x. We get c equals alpha beta plus beta gamma plus gamma alpha into a again from here, which implies c over a equals alpha beta plus beta gamma plus gamma alpha. Last but not the least, d equals minus a alpha beta gamma. Again d by a equals minus alpha beta gamma. We can also bring this negative over here as a whole. Thus the result is alpha plus beta plus gamma equals minus b by a, alpha beta plus beta gamma plus gamma alpha equals c by a, whereas product alpha beta gamma of the three terms, rather 3 zeros, equals minus d by a. Friends, that's all for today. Thanks for watching Edupedia word videos.